Okay, so good day class for our third to the last na chapter sa atong Quantitative Chemistry, chapter 6, the collecting and also preparing na sang aton nga sample because although we first discuss among calculations sa mga sample, okay, it is very important to know how to collect your samples. Also, pag-prepare sa imong mga sample kag pag-preserve sa imong mga samples. So, you have here importance of your sampling. Okay, with a manufacturer list, a chemical or your ECS ta, okay, reagent grade, they must demonstrate that it is conform with your specification set by your ACS or your American Chemical Society. For example, the ACS specification for a commercial nga NABR requires that the concentration of your iron is less than 5, anong ppm tagani? ppm is parts per million to verify the production lot meet this standard. The manufacturer collect and analyze several samples reporting the average result of the products label. Ibig sabihin, for example, isa ka box ang amuna bingis nga mga reagent, okay? You will get random sampling from them to ensure that those bottles has less than 5 ppm of your iron for your NABR. We have here a certificate analysis for your certification or production lot of your NABR. The result of your iron meets the ACS American Chemical Society nga specification but results for potassium does not. Ibig sabihin, ang ginatest mo lang is for your iron but not for your potassium. Okay? If the individual sample do not represent accurately the population from which they are drawn, okay, is what you call your target population. For example, you have a box of your NABR nga reagent. Okay? Ibig sabihin, that is your target nga population. Okay? Then, even a careful analysis will yield inaccurate result. Extrapolating a result from a sample to its target population always introduces a determinate sampling error. To minimize this determinate sampling error, we must collect the right nga sample. Okay? In designing a sampling plan, okay? Para mag-minimize ang imo nga sampling error. Okay? A sampling plan must support a goal for your analysis. For example, a material scientist interest in characterizing a metal surface chemistry in a more likely choose a freshly exposed surface created by a cleaving the sample under a vacuum. Okay, than a surface previously exposed to an atmosphere nga aman because kung mas na-expose sa atmosphere, ibig sabihin mas damo nga contaminants or interference. Muna. So, mas ginapili ya ang mga fresh nga sample kaysa sa mas dugay na nga sample nga kwaon. Okay, for this type of scientist, okay, a material scientist, okay, nga ga-focus sa mga metal surface. Na. So, it's a different type of target yang or although yung target population are mga metals or mga stones muna, okay, the type of sample na gina-require is better nga fresh than your mga exposed na nga stones or mga sample. Now you have here in as quantitative analysis, a sample need not to be identical to the original substance provided there is a sufficient analyte present to ensure its detection. Okay? In fact, the goal of your analysis is to definitely a trace level component. It may be desirable to discriminate against major components when collecting your sample. So, anong ibig sabihin sa mga statement? Okay? Although ang aton nga quantitative chemistry, okay, compared sa imo nga qualitative, your quantitative is answers the questions, di ba, nga how many. Ibig sabihin, mas importante nga may ara gid na ang imo nga or type of your analyte nga ginapangita because you will be measuring the amount of analytes there. Okay, therefore, if the small traces pang arada, okay, as long nga present ang analyte. Okay, for a quantitative analysis, the sample composition must represent accurately the target population, a requirement that is necessarily or necessitates a careful sampling plan. Among the issue we need to consider are these 5 questions. Okay, first na question, from where within the target population should we collect your sample? Number 2, what type of samples should we collect? Number 3, what minimum amount of your sample needed for each analysis? And how many samples should we analyze? Sorry for that. And how can we minimize the overall variance, right, of your analysis? Now, first question, where to sample the target population? Okay, so din ta makuha. Okay, a sampling error occur whenever a sample's composition is not identical to its target population. Okay, if the target population is homogeneous, okay, then we can collect individual sample, giving consideration to where we collect your sample. Unfortunately, in most situations, the target population is heterogeneous, okay, and attention to where we collect your samples is important. For example, due to settling a medication, okay, available in an oral suspension, may have a higher concentration of its active ingredient at the bottom of your container. The composition of the clinical sample, such as your blood and also urine, may depend on when it is collected. Or ang iyong mga patient's blood glucose level, for your instance, will change in correspond to the iyang eating. Okay, ang kung ano last nga gin-intake, ang iyang exercise because gina-consume na ang aton nga sugar sa aton nga body as a form of energy. And also, ang iyong target population shows both your spatial and temporary heterogeneity. Okay, the concentration of dissolved of your O2 in a lake is heterogeneous due to the change in season and to the point source of your pollution. The composition of your homogeneous nga target population is the same regardless of where we sample and also when we sample kag iya nga size ang ating nga sample. Para sa heterogeneous nga target population, the composition is not the same because it is di ba ang term dasang hetero, okay, unlike. For homo, it is the same. Ang muna na niyong tandaan. For heterogeneous nga target population, the composition is not the same at different location, also different nga time, kag different sample sizes. Okay, if the analyte distribution within the target's population is concerned, then our sampling plan must take this into an account when feasible. Homogenizing the target population is a simple solution, although this often is impracticable. In addition, you're homogenizing a sample destroys information about the analyte's spatial and also temporal distribution within the target's population. The information that will be very important. Ibig sabihin, pwede mo ma-damage ang imong sample. Okay, now for your random nga sampling, okay, your random sampling is the ideal sampling plan, provides an unbiased estimate of your target population's property. A random sampling is the easiest way to satisfy the requirement. Despite its apparent simplicity, a truly random sample is difficult to collect. Haphazardly sampling, in which samples are collected without a sampling plan, is not random and may affect analysts unintentionally biases. Ibig sabihin, for example, if you have a box of your NABR, diba? Kuha ka, okay, wala gid sang order. Okay, kuha ka around 3. Diba? Sa next nga box, kuha ka around 1 or 2. So that is your random sampling to check if they are, it is very simple, yan lang. Diba? Next is your judgmental sampling. Okay, the opposite of your random sampling is selective or ang imo nga judgmental sampling, in which we use prior information about your target's population to help guide our selection of your sample. Okay, your judgmental sampling is more biased than your random sampling but requires fewer nga sample. Okay, judgmental sampling is useful if we wish to limit the number of independent variables that might affect our result. For example, if we are studying the bioaccumulations of your PVCs in your fish, okay, we may use to exclude fish that were too small or too young and appeared diseased. Ibig sabihin, may aside sa imong target population ng mga isda, okay, ang imong mga fish or imong target population is gin-categorize mo. Okay, eliminating ang mga bag-o lang, mga newborn nga mga fishes. Okay, mga two fishes nga may mga sakit. Okay, therefore, we will be only targeting your healthy nga mga fishes. Now, your systematic nga sampling, which is the next one, on mouse. Okay, your systematic nga sampling naman niya class. Okay, you have here picture, tandaan na. Okay, random sampling and judgmental sampling represents extremely bias in the number of your samples needed to characterize the target's population. Your systematic sampling, okay, falls between these extremes, in which in your systematic sampling, we sample the target population at regular intervals in the space or sa atong time. Okay, you have here a picture of a lake, okay? This is an aerial photo of Green Salt Lake in Utah. A railroad line divides the lake into two sections. So this is the railroad line. Now, and to evaluate spatial variation, within each, we use two-dimensional grids to define your sampling location, collecting samples at the center of each location when a population is heterogeneous in time and in common clinical environmental studies, we might choose to collect samples at regular interval of time. You have here. So, if the target population sa aton nga periodic threads sa aton nga sample will lead to a significant bias if our sampling frequency is too small. This is a common problem when sampling your electromagnetic signal, whereas the problem is known as your aliasing. Considering, for example, the signal for a simple sine wave figures your here sa dalom, okay, shows an insufficient sampling frequency and underestimating the signal's true frequency or kapila mo gina what. Apparent signal shows your dashing red and passes through your 5 data points in a significant different from your true signal shown sa aton nga as your blue line. For your letter A, name A. Okay, sa imong A as sampling frequency cross sample of 1.5 samples per period, that dash just your red line. Okay, apparent signal that based on your 5 samples are your solid blue line. Then ang imong B, this is your buoyant illustration, a sampling frequency of your appropriate 5 samples per period accurately produces a true signal. Ibig sabihin, may definite or may constant ka nga time mag-perform. Okay, according to English theorem, to determine the accuracy of or frequency of a period of a signal, we must sample the signal at least twice during each cycle or period. If we collect a sample at an interval or sa atong change of time, the highest frequency we can monitor accurately is a change of time, okay, at 2 change of time and raised to -1. For example, if we collect one sample each hour, then the highest frequency we can monitor is every 2, it is 2, di ba, 1 hour. Okay, one sample each hour. So, it is 2 times your 1 hour times -1. Therefore, it is 0.5. Okay, -1. Okay, a period of less than 2 hours. If our signal period is less than 2 hours, a frequency is more than or more than your 0.5 and -1. Therefore, we must use a fast water nga sampling rate. Ibig sabihin, mas makuha ka damo nga sample kag perform. We use this sampling rate at least 3 to 4 times greater than the highest frequency signal is interest. If our signal has a period for 1 hour, then we would collect a new sample and every 15 to 20 minutes. Because 3 to 4 times in an hour, diba? So it is in every 20 minutes. Or kung or 4 times greater, ibig sabihin sa within 1 hour, kaysa nga 1 sample per hour ka lang. So if 4 times ka, so you need to have a sample in every 15 minutes. Now, your systematic or judgmental nga sampling is a combination of 3 balik ko sa bubuhay. No. Okay, it is a systematic or judgmental nga sampling is the combination of 3 primarily approach to your sampling. Also, they are possible. Okay, in which you use your prior knowledge about the system to guide a systematic sampling plan. For example, when monitoring waste leaching from a landfill, we expect a fume to move in the same direction as the flow sa aton nga groundwater. It helps focus the sampling, also saves money kag time. The systematic judgmental sampling plan, we have here sa dalom. Amo natin nga illustration. So, it uses your rectangular grid for your sample and linear transects to explore the fumes limit. So we have here a systematical judgment sampling for monitoring of landfills. The sampling sites shown as your red dot kay diba for your systematic gani. Okay? The red dot is maubra ka sang location, then ang imong red dot will be your sampling area. Okay? So, nag-ubra sa sang grid, pero not in every center siya, but in every intersection. So, dira siya kuha sang sample. So, it already know nga ato nga landfill is diri nga area. Okay? Then, the water flow, okay, or underground water sa dalop sa atong landfill is going sa upper right nga direction. Therefore, the usual nga kuhaan mo sample is dili nga area. So, nag-ubra siya sang grid. Okay, focusing nga this is a 1, 2, 3, 4, 5, 6, 7. 7 by 7. Okay, 7 by 7 nga square. Okay, you have here as a sample area. Sample area that's a bigger nga square. Then another square nga mobra. So you have pila ka sample nga area. It is 3, 2, 7, 8, 10, then 12, 14, and 16. 16 di sa outer pa lang. Then sa atong sulod nga square, na-count na ni. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 13, 14, 15, 16, 17. 17 minus 4. So it is 13. 13 plus 16. So you have 29 ka area or for your sampling site. So correct me if I'm wrong lang sa aton nga kasi glasa lang ko sa pag-count sa aton nga imo nga mga sampling area. Now you have here a stratified nga sampling. So what is a stratified nga sampling? Another combination of a 3 primary approach for your sampling is your judgmental random or your stratified sampling. Many target your population consists of a distinct unit or a strata. For example, suppose we are studying particular PV. What is PV? It is lead in your urban air because particulates come in ranges also sa aton nga sizes. Some visible and some are microscopic. And some come from many sources such as your road dust, diesel soot, and aton nga fly ash to the name as refuse. We can also subdivide the target population by sizes kag other nga sources. We can also choose a random sampling plan, and then we can collect your samples without considering a different nga strata. Okay, in which a bias sample towards your largely particulates. In a stratified sampling nga class, okay, we divide the target population into a strata and collect a random sample from within each stratum. Okay, after we analyze a sample from each stratum, we pull the respective means to give an overall mean for a target population. The advantage of the stratified nga sampling is that individual strata usually are more homogeneous than a target population. Also, the overall sampling variance for your stratified sampling always is at least as good, and often it is better than what is obtained from a simple random nga sampling, because a stratified nga sampling requires that we collect and analyze sample from several nga strata or several nga units. If it often requires more time kag also money. Okay, so we are now sa aton nga convenience nga sampling. Kaya an additional method of your sampling deserves mention is your convenience nga sampling. We collect a sample site using a criteria other than your minimizing sampling error and also ang imo nga sampling variance. In a survey of a rural groundwater quality, okay, for example, we can choose to drill wells at sites selected sa atong nga random, or we can choose to take advantage of mga existing na nga wells. Okay, the latter usually is preferred choice if not because sa aton nga cost and also sa expedience and sa accessibility, and more important than ensuring a random nga sample. So, a convenience nga sample is will the same lang gihapon sa atong nga random. Kaya, pero may choices ka if either you need to make a new way to gather a sample or use mo ang mga old nga mga deposits mo muna. So, what are the types of sample to collect? Okay, having determined from where to collect your sample, the next step is design a sample plan. This is used to decide what type of sample that you need to collect. There are three common methods of obtaining a sample. You have your grab sampling, composite sampling, and situ nga sampling. First, with the grab sample, in which we collect a portion of a target population at a specific time and also location, providing a snapshot of a target population. If our target population is a homogeneous, okay, a series of random grab samples allows us to establish its property. For a heterogeneous naman yung class, okay, a target population, a systemic graph allows us to characterize how its property change over time kag also sa space or amo nang iya nga location. Now, for your composite nga sample, okay, it is a set of graph nga samples that we combine into a single sample before analyzing. Okay, because information is lost when we combine individual nga sample. Normally, we analyze separate each graph sample in some situation. However, there are advantages in working with a composite nga sample. In one situation where your composite nga sampling is appropriate is when our interest is in the target's population's average composition over your kaysa sa imo nga time kag nga space or iyang location. For example, wastewater treatment plants must monitor and report an average daily consumption of treated water they release sa aton nga environment. The analyst can collect and analyze set of individual grab samples and report the average result. Or she can save time and also money by combining all nga mga grab nga sample nga nakolekta niya from different nga site and doing a single composite sample and report the result as her analysis for a composite sample. Composite nga sampling also is useful when a single sample does not supply sufficient nga material for the analysis. For example, analytical method for quantitative analysis of ECB in fish often requires as much as 50 grams of tissue sa imong nga isda, an amount that may be difficult to obtain from a single fish. Combining a homogenizing tissue sample from several nga mga fishes makes it easy to obtain the necessary 50 gram nga sample. Also, a significant disadvantage sa aton nga gram nga sample and composite sample is that we cannot use them to monitor continuous and time-dependent changes in a target nga population. Okay, therefore, ang imo nga in situ nga sample in which we insert nga analytical sensor into the target population and allowing us to monitor the target population without the production line by target population without removing an individual grab sample. For example, we can monitor the pH of a solution in an industrial production line by immersing a pH electrode or pH nga detector in the solution's flow. Ibig sabihin, kada labay sang solution that the pH meter will be triggered and measuring the pH level of that solution. Okay, implementing your sampling na nga plan. So, this is the third part na. Implementing a sampling plan usually involves your three-step. You're physically removing the sample from its target population and also preserving the sample and preparing the sample for your analysis. Except for in situ or insight. Okay? In sampling, we analyze a sample after we have removed it from the target population because sampling exposes the target population to potential contamination or mga interference. Our sampling device must be inert and also clean. Once we remove a sample from its target population, there is a danger that it will undergo a chemical or physical change before we can complete its analysis. It's a serious problem because the sample's property will no longer represent the said target population. To prevent this problem, we often preserve your sample before we transport them to the laboratory for analysis. Even when we analyze your sample in the field, preservation may still be necessary. The initial sample is called your primary or your gross sample. It may be a single increment drawn from the target's population or a composite or a several increments. In many cases, we cannot analyze the gross sample without the first preparing the sample for your analyze by reducing the sample's particle size by converting the sample into a more readily analyzable nga form or by improving its homogeneity. Although we never work with a specific sample highlighted sa ating section, this case study presented helpful sa ating potential problem associated sa mga iba't pang mga sample. So you have here your solution. Okay, there are many examples for a solution sample. Commercially solvent, your mga beverages, mga ginainom ta, such as your milk, your fruit juice, natural water, including your lake, stream, seawater, and also rain. Then you have your body fluids, such as your blood and urine. And also you have your suspensions, such as found in many oral medications. Thus use a sampling of natural water and wastewater as a case study in how your samples or sa ating sample of a solution. Now you have sample collection. Okay, kung paano mag-collect sang sample na gid. Okay, the chemical composition of a surface water, okay, such as your stream or lake or mga estuary or sa aton nga ocean is influenced by a flow rate kag depth or kada lumon. Okay, rapidly flowing shallow streams and also rivers kag shallows. Kaya ang imong lake usually are well mixed and shows a little stratification with the depth. Okay, to collect a grab sample, we immerse a cup bottle below the surface, removing the cup and allow the bottle to be completely filled and replace the cup. Okay, collecting the sample this way avoids the air and water interference. They may be enriched with heavy metals containing with oil. Ibig sabihin, to collect the water sample, okay, from your lake, from your river or mga stream. Okay, simply open a bottle cap, okay, then put it sa water facing sa diin ang flow sang water. Okay, then after na, okay, you do not use the old yang cup but replace it with a new one. Okay nga man, to avoid contaminants halin man sa air. So slowly moving the stream on river, lakes, and deeper than your 5 meters, estuaries, and ocean may show subsumental classification with depth. Graph sample from near the surface are collected as described from above. And sample greater depth or mga sa dalom pa, magkuha ka sample dito halin sa dalom, you're using a sample bottle. Okay, this is your sample bottle. Okay, from aton nga desired nga depth. You have here the cup. Okay, a winch line is the one ginahold or the fishing line. Okay, para sa mga bottle, you have your spring to open the cups. Okay, so okay, so well, from a sample, groundwater are purged before we collect samples because the chemical composition of the water in a well casing may differ significantly from your underground water. This difference may result from your contaminants introduced while drilling the well or by the change sa aton nga groundwater. Also nga redox potential following its exposure to atmospheric nga oxygen. In general, a well is purged by pumping out a volume of water equivalent to several well casing volumes or by plumbing until the water's temperature, pH, and uh, specific conditions is already constant. A municipal water supply such as a residence or business is purged before sampling because the chemical composition of water standing in a pipe may differ significantly from a treated water supply. And also sa aton nga samples that are collected at the faucet after flushing the pipes for 2 to 3 minutes. Okay, samples from your municipal water treatment plants and also industries discharges often are collected as a 24-hour composite. An automatic sampler periodically removes an individual ground sample, uh, adding it to the collected previously. The volume of each sample and frequency of sampling may be constant and may vary in response to the changes sa aton nga flow rate. Now you have here the sample preservation kag preparation. Okay, after removing a sample from its target nga population, the chemical composition may change as a result for a chemical, biological, or physical nga processes. To prevent this class, okay, in composition, some or sa mga samples are preserved by controlling the sample's pH and also temperature by limiting the exposure to sunlight kag aton nga atmosphere. Okay, how do you do that? By adding a chemical preservative. Okay, after preserving a sample, it is safely stored for later nga analysis. The maximum holding time for the or between sa itong mga preserved nga mga sample and also analysis depends on the analyte kag iya nga stability and also sa effectiveness sang aton nga sample preservation. You have here the table below the summary of preservation method and also iya nga maximum holding time for several analytes of importance in the analysis of natural waters and wastewater. So you have here mga analyte mo like your ammonia, your chloride, your metals such as your CRVI. Then you have your metals man, Hg, as your mercury. Then you have metals, iban all metals, your nitrate and organo, chlorine, pesticides, and for your pH. You have preservation methods for your ammonia. Cool it to 4 degrees Celsius and add H2SO4 to sa itong nga pH that is greater than 2. Then, maximum holding time niya or at least time mo before siya ma-expire or madula ng effectiveness ng imong preservation is 28 hours. For your chloride, wala mas requirement. Okay, can be hold for 28 days. 28 hours na naman, but it's 28 days. Then for your metal, cool it into 4 degrees Celsius. Then for your Hg, for your mercury, HNO3 to pH that is less than, greater than 2. Then 28 days man siya. For all metals, okay, add H2S, H2, HNO3 to pH that is greater than 2, and it will last for 6 months. For your nitrate, no preservation method is required. It can last only 2 days. Then you have your pesticide, okay, 1 ml of 10 mg per ml of your HCCl2 or immediate extraction with a suitable non-aqueous nga solvent. It may last up to 7 days without extraction, then 4 days kung binakuha-kuhaan. And then you have your analyzed immediately, ang pH. Okay, it cannot be preserved. Okay, then you have your gases. Typical samples for your gaseous sample includes automobile exhaust, emission from industrial smokestack, your atmospheric gases, and compressed gases. Also included in this category are your aerosol particulates, and the fine solid particle, and also liquid droplets that form smoke and your smog. Let us use your sampling of your urban air in this kind of study sa aton nga gas. Okay, bringing your solid samples into bringing your solid samples into solution. Okay, if you are fortunate, your sample will dissolve easily in a suitable solvent, requiring no more effort than gently swirling or heating. Okay, distilled water usually is the solvent of choice for inorganic salt, but organic solvents such as your methanol, chloroform, and toluene are usually for organic materials. When a sample is difficult to dissolve, okay, you have here mga sample of solution that will help you dissolve mga mga solvents. Okay? Then you have here your solution HCl. Okay, 37%. Okay. Used property dissolves metal more easily, reduce. Okay, duplicate that. Okay, dissolves insoluble carbonate, your sulfide, your phosphate, fluorides, sulfates, and many oxides. Your HNO3, 70%. Okay, strong oxidizing agent. Dissolves metal except your aluminum. AU is gold, PT, platinum, and anong CR? Chromine. Okay, then dissolves, decomposes organics and biological samples. Then your H2SO4, siguro kita H2SO4. H2SO4 dissolves many metal and alloys, decomposes organic by oxidizing and dehydration. Then you have your HF, hydrogen fluoride, dissolves silicates by forming volatile silicon fluoride. And your HClO4, okay, hot concentration solution, a strong oxidizing agent, dissolves many metals and also alloys, decompress organics. Okay, your react with your organic often are very explosive, used in a specific equipment, food, and with a blast shield, and after prior decomposition with your HNO3. Then your HNO, they also known as your aqua regia, dissolves gold and platinum, and your NaOH dissolves aluminum and amphoteric oxide such as your SN, PB, ZN, and your CR. Okay, many digestions now being carried out sa atong closed container using microwave radiation or use of energy. Okay, vessels for your microwave digestions are manufactured using telephone, a Teflon, or any other fluoropolymer that use fused silica. Both material and thermally stable and chemically resistant, also transparent to microwave radiation, and also capable withstanding elevated pressure. A typical microwave digestion vessel as shown sa figure 3.7, consisting an insulating vessel, body cap, and precious vessel relief valve, and yung mga vessel are being replaced by a microwave oven. A typical oven accumulates around 6 to 14 nga vessel, and your microwave energy is being controlled and monitored sa temperature or pressure within one of your vessels. You have here sa microwave. Okay, so this is dissolve na sang imong solvent. Okay, so inorganic sample that resist decomposition by digestion with your acid or base often are being brought into a solution by fusing with a large excess or alkali metal salt called your flux. Okay, after mixing and shaping the flux in a crucible, they are heated to a molten state and allowed to cool slowly in a room temperature. The resulting melt usually dissolve readily in a distilled water or diluted nga acid. Okay, summaries of several common fluxes and their uses. Fusing or fusion work when other methods of your decomposition do not because the high temperature of your flux, high concentration in your molten liquid. Also, the disadvantages includes contaminating your flux with the crucible and loss of volatile nga material. You have the table of your common fluxes. And finally, you can decompose your organic materials by uh, dry washing. In this method, the sample in a crucible or atong nga heat or sa imong oven o sa atong nga furnace, the carbon present in the sample oxidize your CO2 and your hydrogen, okay, including your sulfur and nitrogen as volatile. Okay, these gases are trapped and weighed to determine the concentration of organic material. Often the goal of dry ash is to remove organic material, leaving an inorganic residue or your ash to be further analyzed. So that will be all sa aton nga chapter 6, and we only have 2 more chapters to go sa aton nga finals. Yes. So that will be all. Stay safe and God bless.